Hello Internet! Some time ago I released 3D printable files for Edward Elric's automail arm. A lot of people liked it and used for their cosplay. But I get a lot of questions about print settings, assembly and better ways to attach parts to the body. So I decided to make a new revised version of the model and to make a video alongside it, where I will answer all of those questions, but I will not be covering post-processing like sanding, priming and painting. Maybe in another video. So first, let's take a look at the model. This is the final version of the model. I don't think it's necessary to go over the changes between this and the previous one, but I want to talk about some parts in particular. Let's start with the chest piece. It consists of 3 parts, and I think the separation is necessary to orient each part optimally on the build plate while printing, so we can get the cleanest result possible. In my experience, it is way better than trying to print it as one piece on a big printer, for example. The seam looks like this. It has 2 alignment pins and they must be very snug in those slots. You should be able to insert them with your hands, but it should be harder to get them out just with your fingers. To glue parts together, I use gel superglue, and I will show you later what I did in this particular case. For the rivet heads, you can use sew-in buttons or googly eyes, or you can print them. I included those models too. When you put that part on your shoulder, it will become very obvious that this seam should remain separate so that it can come apart when you move. So this seam shouldn't be glued. It must remain separate. So this part, along with the chest pieces, don't have a flat surface to put on the build plate. So I usually print those on supports without any issues. The bicep is a pretty straightforward part, just a cylindrical shape. It has also a couple of alignment pins, and I think they're really necessary for good clean seam without a step. For some parts of this design, like this bicep, I do have uncut versions, so that they can be printed on bigger printers as one piece. Forearm is a bit more complicated, from the design and printing to the assembly. Let's first start with this, let's call it elbow piece. This piece attaches to the top of the forearm with the M5 flat head screw. 2 screws actually. If you don't have a screw like that right now and you don't want to buy any, you can do what I did and make a small printable insert. Those inserts have basically the shape of the screw, but it's hard to get them out once you inserted them, so the metal screws are obviously better here. Because with those inserts, the elbow piece rotates freely and you can't tighten it up to fix it in place or make it snug, and with the metal screws you can do that. The design includes 2 versions of the forearm, the regular classic one and the one with the blade. The regular top and the blade one have the same geometry where they meet other parts, so they're compatible with the bottom of the forearm and the elbow piece. I spent a lot of time figuring out easy and secure connection for bottom and the top part of the forearm, and I came up with this. There are 2 corresponding indents, in which you can place either magnets or sewing clips. I used sewing clips, I'll show you later exactly how I used them. But if you decide to use magnets, dimensions are 10 mm diameter and 2 mm thick. If you choose magnets, you should keep in mind that here they will be protruding from the surface, It is by design, so they can lock into the indent on the top part. The same applies to the other side of the forearm and to the blade part. You probably noticed that the parts of the forearm are cut in two. It was made so that we can have the flat surface to put on the build plate and to have a cleaner print. But after printing we need to glue those parts together, and to make the seam as good as possible without any steps or misalignment, I use metal pins. I insert them in those small holes. Those pins are nothing more than regular steel nails that I cut to length with the cutters. The nails I use have the diameter of 1.7 mm or something close to it. The top of the palm is a pretty simple part. I just have screw heads separately so that they can be printed on a resin printer or maybe painted with a different shade of metallic. This is the part where I spent a lot of time. I was trying to make fingers look as close as possible to source material and also fit good on my fingers. Obviously every hand is different and your fingers is different than mine, so you will have to adjust those. But don't forget to test fit them with the glove that you will be using. The previous version of this model had some geometry on the inside of the palm, but this time I decided to remove it, because in my experience any rigid part there make it really uncomfortable for your hand to move, and it's not very visible either. Okay, now we're ready to jump into the slicer. Right now I use Prusa slicer. I really like it a lot and it's the slicer of my choice. As I said earlier, some parts don't have flat surfaces to put on the build plate, so we have to print them on supports. In Prusa Slicer we can easily draw supports on the model exactly where we need it. Before placing any supports, I highlight the surfaces that requires them first, and it can be done with this slider. I usually set it to about 45 degrees. If I press Enforce button right now, every highlighted surface will be supported. Some of them can be in hard to reach places, like slots for the alignment pins. That's why I use those highlights as a guide and decide where I want to put the supports myself. Another useful feature that I use all the time is the ability to draw seam lines on the model. It allows me to place seams on the insides of the models where they are not really visible. So this is the preview of the print, and we need to enable seam visualization. Now let's check the supports. As you can see, we have only one small point of contact with the build plate, but everything else is printed on top of the supports. With this part, after a certain height, we have two islands. They start around here, and we need a seam for every island. And again, I'm trying to place them in the least visible spots. Let's take a look at the other chest piece. This part also don't have any flat surfaces to put on the build plate, so it is also printed on supports. This right now is the optimal orientation for this model, to get the cleanest prints and less supports. That's how I placed the supports here. And again, the seams are on the inside. This is another example of the part that must be printed on supports, and this one has a really thin edge. It may look flimsy on the preview, but it printed perfectly fine. In the download you will have a lot of parts for the fingers. They are named appropriately, so you can keep track of which part goes where. This single file has all the finger parts you need, and every part is already oriented optimally. And to keep track of every part, I placed them in specific order. Left to right goes thumb, index, middle, ring and pinky. And from the bottom to top, it goes from the tip to the knuckle. The parts also named in the same order, like 1, 2, 3, 1, 2, 3. All parts from this set are already oriented properly, and some of them need supports, but most of them have a flat surface to place on the build platform. But still keep an eye for overhangs like this. Usually I avoid giving tips about print settings because we have different printers, different materials, different goals and environments. So I will just show what settings I used in this particular build. My default layer height is 0.16 mm with 3 or 4 walls. Usually I don't go over 10% infill with basic rectilinear pattern. I use brim almost every time, it ensures better bed adhesion. The new organic tree supports are awesome and I use them since the beta version. One very important setting is the basic extrusion width for outer walls. For some reason, in many slicers, by default, this value is bigger than nozzle diameter. In my experience, it can cause problems with dimensional accuracy of the print. The default nozzle size is 0.4 mm, and sometimes in slicers they set extrusion width as 0.5. For example, if we print alignment pins for bicep or chest pieces of our build with those settings, chances are that those pins will be a little bit too big and sometimes impossible to insert in slots. So here my recommendation that extrusion width should match your nozzle size. So if my nozzle is 0.4, then extrusion width, like basic extrusion width for outer walls, should be also 0.4. Now let's talk about changing the size of the parts so they fit you better. In my experience, it's better to start with the test print. It's like ordering shoes online. Yes, you can check your foot size properly, but you never know until you try them on. So what I do with any 3D printed armor pieces? I print a test piece with one outer wall and a very thick layer height. The idea here is to print the whole part, but use as little material and time as possible. You can see how flimsy those forearm parts are. But this is plenty enough to understand if it fits you or not. In this particular case, I think you should look for two things. How long the part is. If we are talking about the forearm, if it's too short for your long hand, if you're a tall person for example, then you need to increase the length. Or maybe your arm's thicker than mine, then you need to increase the overall size maybe. Let's say if I was taller and my arms were longer, then I needed to increase only the length of the forearm. Let's jump back to the slicer and try to make an example. After trying out the test print, we, let's say, figured out that we need to make the forearm 5 centimeters longer. But we have our parts sliced in two. So let's take the top of the forearm, it's more or less divided in the middle, and increase the length of the part on the z-axis by 2.5 centimeters. What's important is the increase in percentage along the z-axis, because we need to scale up all the parts uniformly. So now z-axis is 117.9%, and we need to scale all the other forearm parts in the z-axis by the same amount of percents. This lock icon in Process Slicer locks all axes together, so if you want to increase the overall size of the part, that lock must be closed. And if you want to edit individual axes like we did right now, you have to click on that lock and open it. Let's make another example. Let's say the test print is a bit tight on my arm, but alright in length. So we want to do the same thing, but to increase x and y axis and not z axis. Usually with armor pieces, I don't do precise measurements. I try to eyeball it, and even do multiple test prints. Let's say we want to increase how wide the forearm by 5%. And on the preview we can immediately see how much the part increased in size, and we can make some estimates from that. And just like with previous example, we need to apply those 5% increase on x and y axis to every forearm part. So what you see here is a flat surface, in this case it's a door from IKEA, and a 150 grit sandpaper attached with a double-sided tape. Every flat surface that will be glued must be sanded very flat to minimize any possible gaps. Also, sandpaper roughens up the surface so that the glue can do a better job holding pieces together. Look at that seam, no gaps at all. And I'm not talking only about big obvious gaps, I'm talking about print texture, like layer lines and stuff. It doesn't matter how good your printer is tuned or how sharp the corners are. That kind of preparation will make the glue up stronger, no matter what kind of glue is used. That surface is not sanded yet. Take a closer look at the edges. And this one is ready for the next step. It may be not very comfortable to sand a flat surface on a such small surface area like this. So I'm pushing down while I'm sanding to maintain this plane. And I'm trying really hard to not rock this part on the edges while I'm doing this. The video is sped up, but I'm taking this very slow and steady. I'm trying to match those surfaces to inspect for the gaps, but it proves to be a bit difficult without alignment pins. Before moving to the next step, I'm wiping and cleaning every sanded surface to remove any remains of the dust. I start with gluing alignment pins in the slots. This way they can provide additional structural support. For FDM prints I usually use gel superglue because it's thicker and it fills in the gaps, which makes the bond stronger. If you have a lot of glue squeeze out, it's a good idea to wipe it immediately, because if it hardens, it will be in the way of the surfaces actually touching each other. As you will see later, I wipe all excess superglue immediately. I apply a generous amount of superglue on one surface, trying to put a bit more closer to the edges of the surface. I want to have a good amount of glue squeezed out of the seam. And this time I let it dry. Dried glue acts as an additional gap filler, but from the inside of the seam. I only wipe the excess on the inside of the part, because I will not be blending those surfaces there. I apologize for being out of frame. I was trying to get a better look at the seam while I was gluing it. Okay, now it's time for metal pins, or nails. I cut the ends, insert them in the slot, and then roughly cut it to desired length. One very important advice: before any glue up, always do dry fit first. Then again, I glue in the pins first and wipe the excess glue. And another dry fit. Here I want to remind you about safety. Please do this in a well-ventilated area. This is a lot of glue, a lot of surface areas from which that glue evaporates, and it can irritate your eyes and nose. After I finished gluing grey parts, I wanted to check how it fits on my body, and I wasn't satisfied with the result, so I decided to make another revision, another correction to the shape, and this lovely Barbie color is the latest version of the model, and I am gluing it up all again. Here's the closer look at those metal pins, also known as just regular nails. On some parts, slots of those pins will touch the build plate, and if, for example, your first layer is squished really hard, it may seem that the holes for those pins are too small. But they're not, actually. You just have to open them up a little bit. Now everything is glued and we can move to the next step. This is how I used sewing clips. This is one side of the clip glued in with the super glue. drops in that indent. Gel superglue holds it pretty good. The other side of the clip goes in the deeper indent. They look a bit rough because I applied a little bit too much glue. And this is how it works. You have to squeeze the bottom part a little bit so that sewing clips fall into place. It's very secure and easy to disassemble. When installing this part of the clip, keep in mind orientation. After some trial and error, I found out that this orientation is optimal for longevity of the clip. At the moment of filming this part, I didn't know about better orientation for the clip, so I placed them randomly here. This one is placed correctly.
So, while I was testing all of the finished parts, I was looking how the sewing clips that I used here, how do they hold up? Because we want them to work nicely for a long time, not just for a couple of times, right? So, and I found that they have one issue. So, take a look at this guy. Focus, please, focus. You see here on the top part, it's a little bit bent, and this like spring, metal spring, it's deformed a little bit. I don't know if it's, yeah, on this angle it's visible that this part is bent. It is bent because when the pin comes out, it comes out on like going top, so going up. So yeah, this is damaged during my suit up and disassembly every time. I used it quite a bit while making this model, while testing those prints. So it took quite a lot of beating, but this is the only one that behaves this way, and it actually doesn't lock anymore. The all other clips lock perfectly fine. Why? Because not that. Yeah. Because, please focus. Because the way pins those springs, those small metal springs aligned, makes it harder to like bend the stuff. So right here they're going like this, so when the pin comes out up, it doesn't damage the spring. So I will show you on the other part. So yeah, this example. So one spring, second spring, and it's not perfectly up because I was gluing them randomly, but it's mostly up.
Well, at this moment I had some extra printed parts from the previous iteration, printed in gray color, and I wanted to test the seam for durability. And I decided that the best way to do it is just smack some parts on the table. It was a pretty strong hit, but as you can see, the seam held up fine. What's broken is the plastic itself, the PLA filament. Let's hit it some more. And again, plastic is broken, but the seam is intact. Obviously, I don't use very good or expensive filament for those tests, so it's not the strongest PLA you can find. Especially that blue one. And the same result here. You can see that the part is broken where the metal pins end. For this reason, when I make some prop swords or something long, I try to insert some metal inside, like aluminum tubes for example. Now let's test this piece. This one has a lot more surface that is glued together. I'm going to drop it on the floor from the different heights. The floor is quite hard. No damage yet. I'm not trying to say that gel superglue is some kind of superior or that seam line is so strong that you can break it. Any seam line and any glue up will break if you apply enough pressure or impact. But I think it's very important to prepare the surfaces for the glue up, like I showed earlier. It makes a big difference. This one holds up really good. Now, once everything is printed and glued up, we can start figuring out how to connect the pieces to the body. And we are starting with the fingers. I want to glue finger parts to the glove with the hot glue, but I don't want to burn myself. I'm sticking a little bit of masking tape to the glove so I can mark the placement of each finger piece, so that when I take the glove off and start gluing the pieces, they will be exactly where I need them. I've printed a mock-up of a hand that slightly resembles the length of my fingers, but the fingers itself are much thinner than mine. But you don't have to print something like that. You can do this even with some wooden dowel or any cylindrical shape that is close to the size of your finger. At this point of my prop making career, I have enough skin burnt by the hot glue, so I'm trying to keep it on the safe side. I'm using my own hand here instead of the mock-up when gluing the ends of the fingers, because I'm applying glue where the fingernails are, so I can't burn myself that much. And for the smaller parts I also use my hand, because they require just a tiny little bit of glue. I've tried different types of gloves for the base, and my recommendation is that the glove shouldn't be too stretchy, a little bit is fine, and it shouldn't be too thin, so you don't burn yourself. If you can choose the fabric and sew your own gloves, it will be the best option. Also, because how it fits. The glove I use I ordered on the internet, and it's a little bit small for me. I secure the top of the palm with a couple of velcros, so that you can put that part after you put the glove on. This is how much time, effort, testing and printing it takes for me to get the result that I'm happy with. For the forearm parts, I decided that the most secure option would be to attach top or bottom to the hand first and then the other part. So here I'm gluing up some velcros to the blade part. For the regular version I used velcros and elastic band. Okay, here I want to show how I attached the shoulder piece to the chest part. This is actually pretty simple. There is, as you can see, a black elastic band, like sewing elastic band, like here, and it starts around this seam, as you can see, and on the other side as well. But I marked the position here because before gluing I took the shoulder and placed it like from the top, like this, and mark this position and glued the elastic band from the inside. And the way it is glued right now, like here, right? It allows some kind of movement. This little part on the top is also glued on the inside using the same elastic bands. One side to the shoulder and the top side to the chest part. So when you move it, it goes up too, like as you can see. Yeah, and this little decoration part also hot glue and elastic band. About those two straps, those are for attaching it to the body.
Also, I want to point out something about the bicep part. So, right now it's not fixed to anything because it sits stuck on my arm. I can't put it up more, like it's snug. But I think it should be somehow fixed either to the sleeve or to the shoulder part, like inside there. Like maybe some couple of straps, or if you're connecting it to the sleeve, you can use some sewing clips or Velcro. Because right now this part, when this part collides to the chest part, it may be uncomfortable and pinch a little bit of skin here on the back. Right now, when I move, this part wants to slide backwards like this, like here. And when it does that, it pinches a piece of my skin around here when I move my arm backwards. So, if you, I think this part also should be attached to the sleeve or to the chest part, maybe both. So it should stay in line with the shoulder piece, like and those like plates, they should look to the side, not back, not forward, straight to the side. So like this, like right now, because when I move forward or backwards, it doesn't pinch my skin and it's comfortable. So yeah. And also, if you attach it to the chest part with some strap, or to, like, for example, you can attach it here and here and make a strap. So it will also prevent this part from sliding down. Like you see, it slides down, and when it slides down, it interferes with the forearm part, and the forearm part sits very nicely. So we don't want any of that. So yeah. Another point about the arm, like palm part. I think it would be beneficial to attach this glove using, for example, Velcro to the inside of this top forearm part, so that when you bend your arm like this, it will not come out like that, and your hand will not be visible, but it will be attached back there like this. And also it will help to finger parts to stay in place, because when you move your arm, they may come loose a little bit. So yeah, maybe some Velcro like right there on the inside for the glove with the fingers and the stuff.
I want to point out that this is not a 100% finished prop, it's just a test print. If I was doing a fully finished replica level prop, I would glue all the elastic bands, straps, velcros and sewing clips after the final painting process. Also, as with CA glue, before hot gluing all the straps and velcros to the parts, I recommend to roughly sand the gluing spots with some coarse sandpaper, like around 100 grit. If you are worried that some parts will rub together a lot and destroy a paint job and the finish, you can glue some soft fabric on the inside of the parts, for example on the shoulder piece, on the big shoulder piece. Wow, that turned out to be a lot longer video than I expected. But I hope all of that information will be helpful if you build Elric's automail or any other kind of prop armor. I wish you good luck and patience with your builds. See you around.